to today's lecture. Um, I'm going to work through this one. As I mentioned, we saw the graph of this, so I'm going to also take its derivative. I think I can do that. But looking at the graph, we can kind of see there are mountain tops 1, 2, 3, 4. I can mark those. So there's one here, one here, one here, and one here. So those are going to be some. So we would expect to see four maximums. In the middle down here, you can kind of see the translucent part in the middle at 0. I don't know if that's 0, 0 or not, but it's down in there. Z-axis, it looks like it crosses. We're going to get one minimum. And then there's these saddle points here. So that's where we've got a minimum in this direction, right? We come along this edge. But if we go in the y direction, we go up, and then inside we go back down. So we've got a minimum and a maximum. That's what a saddle point gives us. And I can see there's going to be 4 of them in between each of these mountains. So 4 sacred mountains, 4 sacred valleys, and 1 big valley in the middle where everything goes down to. Let me erase these so I can, I want to move it around. And the 3-dimensionals, a lot of times, for me at least, I kind of have to grab them and move them, right? So I can kind of see that what's going on there and it's going down in there. Would be cool is you could probably do a 3-dimensional, get a 3D printer. We could print this out and see it in real time rather than just sort of in this virtual world. But so what I'm going to do, I'm going to take the first partial derivatives with x and y, set those equal to 0 so we can find the critical points. Again, I guess I can finish writing here, 4 saddle points. So from what I can see, we should have 9 critical points on this one. So what I'm going to do is I'm going to use Microsoft Word and go down here. I'll just use the draw feature. Sheet. Okay. So we're going to start with the function z. I'm going to go ahead and distribute this 2 through. It doesn't change anything, but I think it'll make it easier to take the derivatives. 2x squared plus 2y squared minus x to the 4th plus y to the 4th. Actually, this should give us some fairly clean derivatives. We're going to take the first derivative. We could write it as z with respect to x, or again, we've been thinking of this as some function in x and y. That gives us that third variable z. So I'm going to just keep going with f as our function. Take the first derivative with respect to x. 2x squared, the 2 comes down. 2 times 2 is 4. X to the first power. Derivative of y squared is 0 because it is a constant, so this term is just gone. Minus x to the 4th, the 4 comes down. I now have x to the 3rd. So that is my first derivative with respect to x. And then the partial with respect to y, it's something very similar. Derivative of x is 0. 2y squared, so the 2 comes down. 2 times 2 is 4. Subtract 1 from the exponent. 2 minus 1 is 1. Derivative of x to the 4th is 0 because it's a constant. And so y to the 4th, the 4 comes down. Wait a minute. There's more to this than meets the eyes, right? Oops. Let's see, bring it back. Um, let's see, I think I can bring, yeah, okay, +1. So I didn't have the full function. The other thing I got noticing, I'm going to have to distribute this negative sign through. So let me, the basics if you make a mistake. So it's actually be a minus here because I distribute that through, and then I got a +1 that I forgot about. Now when I take the derivative of +1, it's all disappears, so that's not a big deal. But it's a big deal over here that this is a negative, not a positive, -4y to the third. Okay. We're going to, so that's step 1. Move this up. How are we going to get 9 points out of this, right? I'm going to rewrite this. Actually, I'm going to set it equal to 0. Save myself some steps. So setting it equal to 0, I'm going to factor this as 4x 1 minus x squared. Might be kind of cool. Do the same thing for the y. We're going to say we set it equal to 0 because we're looking for horizontal tangent lines, horizontal slopes. Slopes of 0. I'm going to factor out a 4y. These should be almost reflective of each other. 4y. And what's left behind is 1 minus y squared. Actually, I could solve one of these and I'll figure out what the others are in terms of that. So certainly 0 equals 4x is one answer. So I get x equals 0. And then I get 0 equals 1 minus x squared. That's a difference of squares. I could write that as 1 minus x times 1 plus x. Right, so we get negative x squared. We get a +1. We get a positive 1x, a minus 1x, so there's no middle term. And so this gives us actually two answers. Either 0 is equal to 1 minus x, or 0 is equal to 1 plus x. This one, add x to both sides, you'll get x equals 1. This one, subtract 1 from both sides, you'll get x equals -1. So we get 3 different values for x that will produce the x, the derivative in the x direction. That will make it 0. We will get those same type of answers with y. So all of these, I won't go through the steps. You would go through the same steps. They would look exactly the same, except instead of an x, you'd have a y. So we also get y equals 0, y equals 1, and y equals -1. Now, each of these will produce a 0 derivative in the y direction. So the only way we can have a 0 slope in both directions is to have these put together. So I can combine, this is one critical point, 0 with 0, 0 with 1, and 0 with -1. So I can, as long as x is 0, this is going to be 0. As long as y is 0, 1, or -1, the derivative of y is going to be negative. So this makes these points both x, we've got 0 slopes in both the x and the y direction. So those are 3 critical points. We do the same thing with x, and notice we're going to get the same thing. So if x is 1, we will get a critical point as long as y is 0, or if y is 1, or if y is negative 1. And then if x is negative 1, do the same thing. We combine it. Y is 0, y is 1, or y is negative 1. So these are our critical points, and notice we have 9 of them. And we had 4, 4. So we're expecting 4 of these to be maximums, 4 of these to be saddle points, and 1 of them to be a minimum. And I think from the graph we saw that 0, 0 was a minimum. What I'd like to do now is I'm going to go in, take the second derivative, and let's apply the second derivative test and see how it is, and then we'll compare it to the graph itself. This is, I don't know if I call this fun, but it is a exploration, intellectually stimulating. We'll call it that. Okay. So let's take, these are our critical points. I can scroll down, and so we're just going to remember we're going to take second derivatives of each of these. I think you can kind of see that the derivative, the second derivative of each with respect to the other variables is going to be 0, but we'll work that out. Okay, so we're going to come down. Let's see, what should I do? We'll come down here. 4x minus 4x cubed. Okay, give ourselves some more room. So we've got, this was the first derivative. Now we're going to look at the second derivative. Derivative of x here is going to be just 4. This is going to be 4 times 3 is negative 12x squared. Now we don't set that equal to 0. Remember, we're going to use that Hessian formula. We'll take the derivative of x with respect to y. And again, we only really need 1 because we're going to square this, and the other derivative of y with respect to x would be the same. So we come here, 4x, that's a constant because we're doing the y variable as our y is our variable. So this is 0, this is 0, its derivative is 0. And then we just need this last one here, which was 4y minus 4y cubed. So we take the derivatives. So the derivative of y with respect to y is going to be 4. Y is 1. 3 times 4 gives us negative 12y squared. Now the Hessian is this formula where we take, and a different thing. So we take this times this minus this squared. 4 minus 12x squared times 4 minus 12y squared minus 0 squared, right? 2 of these. So that's our Hessian. I'll put the big H. And again, if the value we get from here is positive, then the point will be either will be a maximum or a minimum. If the value we get here is a negative value, then we have a saddle point. If the value we get here is 0, then it's inconclusive. But I don't think we're going to get that. Now, you could FOIL this out or multiply it out, but I'll tell you what, I think it'll be easier to take these points and plug them in and do the calculations without having to FOIL it out. I think so. So what I'm going to do is, what is the Hessian? Let's do this in black. So, ooh, not that one. do the Hessian of 0, 0. That's just my own notation I made up. I haven't seen it in the book, but I think it's appropriate, right? We're going to plug this point up here into the Hessian to see what we get. So we're going to get 4 minus 12 times 0 squared. Four minus 12 times 0 squared minus 0 squared. See, this back part's all 0, so we get 4 here. This back part's all 0, so we get 4 here. So we have 4 times 4, which is 16, positive 16. It's a positive number. So that means we've got a minimum or max. Figure out which one it is. We look at what is the value of f(x)(x) alone by itself. Well, that's going to be just 4 minus 12, 0. It's going to be 4, which is positive. Positive makes you smile. Then we're going to get a minimum. So this point, 0, 0, is a min. Just label it there as a min. It's a minimum. And we saw that, right? We come over to the graph. We can see that point there, 0, 0. At least both x and y are 0. Z is not necessarily 0. 0. Z looks like it's maybe at 1, right? Because you have this plus 1. But x and y are 0. Down here. Yeah, we can see that. 0, 0 for x and y. Get it upside down. Okay. We okay? Again, maybe we won't do all of these. I don't know. You can always drop off the video anytime you want. But let me do a few more of these. So we're going to do that. So that's a minimum, like we thought. 0, 1. I think all these ones. So I think where the mountains are going to be at. Let's see if we can guess. All the ones that are 1, 1, 1, negative 1, negative 1, negative 1. I think that's these guys, right? Look at these. The saddle points all have one of them that are 0, right? So we're on the x-axis or the y-axis. These two have x values of 0. The ones that are on the x-axis have x values that are 0. But these are all maximum. So the ones that are all 1, 1 something, all going to be maximums. And what that means, so let's just take one of them and see how that looks, and then we'll see if that works for the saddle point. So I'm going to take, let's take this one. Anything with a 0, a 1 and a 0, this should be a saddle point. If it's a saddle point, when we do it into the Hessian, we will get a negative number. 1, 0. Put in 1 for x. 4 minus 12. Yeah, see, that's why it's going to be negative 1 squared. It's going to be negative 12, right? Over here, we're going to put in 0 for y. You're going to get 4. This part, the second part, is going to be 0. So you just get 4. So you get 4 minus 12. It's going to give you negative 8 times positive 4. That's still a negative number, negative 32. Subtracting the 0, of course, that didn't do anything. So the Hessian is negative. That tells us we have a saddle point here. And you'll see that will happen with all the ones that have a 0 and a 1. This gets squared, so that's going to become positive, but then you'll see all of those. Those are going to be our saddle points. So saddle point, saddle point. And again, we could see it from the drawing. We can also do it with the Hessian, because when we plug these in, the Hessians will all become negative, which means that these ones here are the mountains. Those are our local relative maximums. Looks like they're also absolutes. But when we plug this in, what's going to happen is the Hessian will be positive, and then f of x, when we plug it into just this part, that's going to be negative. So let's verify that. And I'll just kind of do it up here. So we'll do the Hessian. Let's just do 1, 1. So that's going to be, and using this red here, 4 minus 12, 1 squared, times, same thing, 4 minus 12, 1 squared, minus 0 squared. Okay. So in this one, we're going to get 1 squared is 1 times negative 12. 4 minus 12 is going to give us a negative 8. Here, we're going to get negative 12 times 4 minus 12, which is negative 8. Negative times a negative is positive, 64. So that tells us we have a max or a min, because it's a positive value. And to determine which one we have, we look at f of xx, just that part. And we could see, we've actually calculated as we went, it's going to be negative 8. A negative makes you frown, which gives us a max. These here are all maxes. These guys here. Saddle points. So I'll post this in my YouTube channel. Hopefully it's helpful. Again, if it wasn't, I guess you would have cut out early. But anyway, good luck on your studies, and let me know what questions you have. A few people have been stopping by for office hours after class. Remember, I'm also available before class. I'm in a Discovery Hall up on the 3rd floor. I think it's 312, 313, something like that. Just come over to the American Indian Student Support Services. That's what we're there for, to support students of all kinds. That's me. And if you need me after class, I'm usually available. I don't. This is my last class of the day. I usually come back to my math office and do things like this, make videos or whatever I do. But I'm available. So I do go home at some time. I don't sleep in my office much anymore. I used to, and if I did, I wouldn't tell anybody. So, but no, I go home. I do have a place to stay. So. But contact me, and I'd be happy to work with you after class as well. Take care. Hopefully this was helpful.